Morning everyone. I'm Robert Taylor. I currently work as an environmental scientist for Raw Technology. Just been invited by Jen to do this sort of presentation for you today. So quick run through what we're going to go through. Just brief introduction to me and the company I work for to give you a background of what I do, and then go into more detail about what I do day to day in terms of investigating oil spills. So we deal in hydrocarbon spills predominantly, and the remediation techniques that are associated with that. Also go on to client and project management, the aspects of that I use in my job as well, and briefly go on to challenges which the contaminated landfill sector faces. There's going to be elements of this that you might not understand or I might not explain perfectly. So if you've got any questions throughout, just raise your hand and ask them, and I'll answer them as we go along. And if you can also think about the skills that you have now and try and see how you can fit them in to what I'm explaining, because there might be something about that later on. Get ready for a bad photo as well, because that's me in 2010. So I came to Manchester between 2007 and 2010. Went straight on to do the environmental monitoring, modelling and reconstruction masters here at Manchester, and during that time managed to get work with Raw Technology initially as an environmental technician. The technician role is basically the skivvy, so you go around doing all the site work for everyone, take the soil samples, all the hard boring labour that the project manager or the scientist doesn't want to do. Shortly after that, got promoted to be environmental scientist. I'll run into more detail what that does later on. And then early next year, I've started a new job with the company, which is a remediation engineer covering the north of England. We'll go through some of the remediation techniques later on in the presentation, and it's those sort of measures that I'll be conducting for the project managers within the company. Okay, so a bit about Raw Technology. We've existed since 1998 when we were established. Originally just 2 people and a shovel. Now we're up to 130 staff across UK and Ireland, and I think it's, you can count it yourself, but I think it's 16 offices. I've also got a project that we've got over in Shanghai in China, and a few other projects around the world as well. That's a market that we're trying to sort of get into. Turnover last year, £11 million, and that makes us profitable. What we go for is the response, remediation and regulation aspect of the market. Because we're a hydrocarbon spill company, we respond to things pretty quickly, so we might have to go and help people out within a few hours of getting an instruction, ideally. The other market is remediation, so that is when there's a bulk of contamination somewhere that's been identified. How do we treat that soil? How do we remediate it to make it safe? Because we risk assess against things like human health, risk to the environment, which includes aquifers, groundwater streams, things like that, and also abstraction boreholes that may be around for people's water supply. And that's all sort of governed and encompassed by regulations, sort of with the law, and the Environment Agency will sort of pull us up on that if it's not done. So our clients are primarily through insurance companies via loss adjusters, and these act as people, a go-between between a policyholder who has a so what will happen is they'll have a central heating system that's powered by a kerosene supply, fuel supply, because they can't get electric or gas. These weather over time, or things crash into them, they fall over, the land subsides, but the tanks crack, the pipes crack, and you end up with contamination spreading out over the ground. But also if it's next to or near their property, it can get in there as well and cause harmful odours inside that can, carcinogens, some of them, so cancer forming, just make you feel nauseous and ill. So that's one of the prime reasons why the insurance company wants us to go in and remediate it, because it reduces that risk. The other sectors we supply are water companies, where we might dewater an excavation and treat the water that comes out, and also large-scale building contractors, where we might either remediate the land for them, conduct environmental assessments, or even act as their spill response agency. This is just a snapshot of some of the companies that we've worked with in the past. You might recognise some of them. Most of them are instruction or utility based. So yeah, our main capabilities are the spill response sector, where we get out to the sites pretty quickly, assess the situation, and then we carry out the remediation processes, which we'll go on to later, and provide technical and expert services as well. And that can include acting as an expert witness in a court case. So person A is suing person B because person A's oil spill has devalued their land, perhaps. And we act as an expert witness to say how contaminated it is and what impact it will have had. Right, so basically an environmental scientist is essentially this. It's a project manager, so I have a bulk of projects that come into me, and the first job we have to do is investigate the extent and severity of the contamination that's there, and that's allocated to the spill of oil that's been reported at the time. So you might be on a site, say, where there's been a lot of contamination in the past, but you might have to just focus on the 200 or 300 litres loss of kerosene that's happened. And you also, sometimes we have to, a building company or development project will want to sort of build an industrial unit on a site. They'll have to do a pre-use land environmental assessment, so assess what the contamination levels are presently in the land. And then following their completion of work in, say, 20 years' time, they'll conduct another one. So we get involved in those processes as well. And it's the responsibility of me to sort of manage that. An element of that management is to provide a remediation strategy. So find the contamination, establish where it is, delineate it, and then come up and suggest with a strategy to reduce the identified risks and make it safe. And along the way, I was managing relationships with the client, site owners and regulators. There are the sort of aspects of that I picked up at university, particularly in the third bracket with things like communication skills, sort of planning. You need to plan your day and your week and your month around what you need to do. So you need to be organised. And there's also an environmental science background also helps, because you need to know about things like hydraulic conductivity and soil profiles, drift and bedrock deposits, things like that. And also how to read maps, so they're pretty useful. The first point that we mentioned is investigation methods. So imagine I get a new project in and it's Mrs. Miggins over in Wales. She rings me up and says, Rob, I've had a spill of 500 litres of kerosene after I've had a delivery of oil. I think I can smell it inside the house. Can you come and have a look? So go over. The first thing you need to do is risk assess inside the house. If you think there's an odour inside the house, we need to monitor the contamination that's there. The way we do that is with that yellow thing down at the bottom. That's called a photoionisation detector. That basically picks up the VOCs that volatilise off the hydrocarbons, and it's a really good in-field indicator of how contaminated an air is. If it's too high, we might have to put a sort of fan in to sort of extract the fumes out, and that way they can safely live in the property. If the odours are still too high, then we suggest to them and the insurance company that they move out, because it'd be dangerous for them, particularly children and pregnant women as well. We also use that device to sort of delineate the impact to masonry. So Breeze blocks and bricks will soak up the kerosene and then volatilise from there. So sometimes we have to treat that, but first we need to delineate it, and we use that to do that. In terms of the soil sampling, what we need to find is the contaminant plume. The first thing you really need to know is how much you've lost. If they've lost 50 litres of kerosene, it's not going to be a huge issue, so you're not going to find a huge plume. If they say they've lost 2,000 litres of kerosene, then you've got a big problem, and you'll end up with something like that. The bottom left square there, where you sort of dig a trowel pit down through the soil and you hit the perched groundwater, and on top of it you've got a lens of hydrocarbon. And that's obviously a really clear and obvious indication that you've got contamination there. In terms of soil sampling, to delineate the contamination plume outwards, you want to hand auger down through the soil profile. And once you're collecting these soil samples that you get from that hand auger soil bore, you can then in-field screen it with the PID at the bottom, and that'll give you another good indication of where it is. We build on from these in more detail by sending them on to a laboratory here in Manchester, who analyse it for TPH compounds, BTEX and naphthalene as well, because they're the compounds that we risk assess against in terms of human health. So obviously some of the skills that you guys might have already for this are things like logic and delineation. If you've got contamination here against the house, you can't just go away and say, oh, it's just there, because we need to delineate. We need to know how far it is, because that will have implications on the length of the project, the cost, the amount of work you might need to do. So if you've got soil sample A that's contaminated, you need to sort of delineate it laterally on the ground and also through the soil profile. And when you go through the soil profile, most of you will know that you get perched groundwater in the drift deposits. If you're finding contamination there or at depth where you can't hand auger down anymore, then you need to get into the sort of realm of that of a monitoring well, groundwater monitoring well, which we put in with that machine that's at the top. So that's called a window sample rig, and they turn up, drive over the site where you want the hole to go, and smash through a core of soil, and then install basically a well where you can sample from. And the picture at the top right is an example of that water sampling being collected. There you've got quite a lot of kerosene on the surface. We don't see that very often. That's very rare, but it's a good indication that, you know, following your investigation, you've definitely found hydrocarbon contamination. And we can't leave that in because it's a risk to the rest of the aquifer around it, because it's going to create a contamination plume on top of the groundwater. It's going to cause a contamination plume in the dissolved phase of the groundwater around. And that can also migrate across that. If it gets into a watercourse, and say you're in a triple SI site, if it gets into the watercourses, it will oxidise that water and basically kill a lot of the wildlife that's there. Nobody wants that, least of all the Environment Agency, so that's one of the reasons why we treat it. Also, with the rising groundwater, as it moves up and down, it will take that kerosene with it, and as it does, it will smear the soils above and below. So you're actually, the nature is actually contaminating the site for you. Other things you can look out for are if underneath someone's floor in the house, you might get their damp-proof membrane that sort of pickles and degrades, and the insulation underneath can melt as well with the kerosene, and that can cause subsidence and cracks in floors. Ultimately, because most of our work is through insurance companies, they don't want that to happen to their houses, so they like to protect that. So yeah, some of the skills that you might have, you've got. Is everyone aware of things like accuracy and precision in work? Yeah. So the accuracy of your samples, so you might take a soil sample from, say, a metre down, or let's say half a metre down on the floor, but then you go up to the raised garden that's another metre up and you take a soil sample from half a metre there. Now, if you label both those as half a metre on a plan and to the client, that might mean that it's the same level. So you need to take into account the depth of the soil and create an accurate profile. And that's the same if you have to go into cellars as well and investigate in there and the soils around there. And then being precise, you basically want to use the same sampling strategy and procedures. You've probably all had experience with soil sampling or some sort of site sampling strategy, and you just employ those same techniques, but with the logic of if there's contamination here, find out where the contamination ends, and then you can pull up a plan to get rid of it. So I'm going to go through some examples now of remediation processes that we can do if we find a bulk of contamination. Does anyone have any ideas of how we might treat or remove contamination? Say if we've got say if it's over there and it's away from someone's house and it's just in someone's garden. Anyone think of anything? No one? Yes, excellent. So yeah, first and most obvious thing to do is to dig it out. That is called ex situ works. And it's the same for the masonry. We use that PID to delineate exactly where it is in the masonry. It's basically the same as doing it in soils. So if it's in the soils and it's at the top and it's top surface and we get to it easily, the most effective way to make sure that the contamination goes pretty quickly is to just dig it out. That can vary in size. That can vary from, say, a couple of metres squared to 40, 50 metres squared to maybe like a couple of metres depth, depending on where it is and how easily you can get to it. In terms of the masonry, it's difficult to sort of treat that in situ if there's so much kerosene soaked into it that it's volatilized. It will also damage the damp-proof course around the house. The damp-proof course, for those who don't know, basically stops any water rising up into the floor and into the rest of the house, so it stops damp getting in. And once damp sets in, it's difficult to get rid of. The other thing we can do is treat the soil. The large and complicated looking machine down there is something that we own. I'm not sure if we developed it or not, but it's something that we definitely own. It's over in China at the moment, in Shanghai. What happens with that is soil gets loaded into it and it's somehow treated. I'm not sure on the mechanics of it, but it's somehow treated to a point where it's much less contaminated than what it was originally. And that's a way of sort of reducing your impact on landfill, and also your treatment costs come down as well, which is important to consider. The rest of the techniques that we use are a bit more complicated, and these are things that I picked up on when I was in the job. So before, when I was at university, I didn't learn anything about this, which I had because it was really interesting to me anyway. But let's say we've done your suggestion up there and we've dug down as much as we can, but we've still got contamination underneath. There's a number of other methods we can use. Number one being soil vapor extraction. So remember I was talking about the VOCs that come off the hydrocarbons. Basically they're always volatilizing off. So if we push some lances into the soil which are perforated and attach pipes and a fan to that, we can draw out all the vapors that are coming off, all the volatiles, and you'll be able to monitor it with the PID. At the start it'll be quite contaminated, and then eventually it'll come down, and you're just reducing the natural volatilizing process of the hydrocarbons. The other thing you can do is an ISCO treatment, which is chemical oxygen. So we pump in a chemical into the ground. It breaks down the hydrocarbons, and then you can go back after a number of treatments, sample again, and your concentrations of TPH, BTEX and naphthalene will have reduced dramatically, and you'll be able to what's called validate the site. And that's the key really. Once we've investigated it, found the contamination, if we do 6 months worth of remediation and it's still, and we take a sample afterwards and it's still contaminated, like what's the point? We'll get in trouble, we'll look rubbish, and that's no good. So we want to prove that what we've done has worked, and by doing that we just take another sample, analyse it for the same things, and then compare the difference against our risk assessment criteria. Is everyone keeping up with this so far, yeah? Any questions? No? Okay, good. So the top left picture there is the chemical oxidant being mixed. That is pretty harmful stuff, so you have to dress up in like a full face mask and filters and like the chemical suits. When I first did it, I felt pretty cool actually, but novelty soon wears off when you're trying to take them off afterwards and they're all ripping. It's no good. The other thing, bearing in mind, is the large picture there, bottom right, is a more complicated form of the SVE. So that's the SVE treatment there. So the lances are at the top, going into the ground, and then the fan box is there with what's called a knockout pot, which gets rid of any water. The pipe work at the bottom is part of what's known as a dual phase remediation system. And in that element, because we're in a cellar there, we've got a low water table anyway, but we've still got a huge profile of soils that are contaminated. So remember I was saying that the water table rises and will smear the contamination up there. So we want to pump out that water that's contaminated first and foremost, and then it also draws down the water table, and you can implement the SVE system around it as well. So as the table's gone down, the soils at the left, you're taking the volatiles away that have smeared again. And you basically do that until all the kerosine's gone and there's low readings on the SVE. The other two photographs, so the top right is what's called a gas-resistant membrane. So they're underneath someone's floor. It's like a barn conversion in Derbyshire, that. And they had a spill of oil from a boiler which is located upstairs. And we had to dig all that floor out because they lost, I can't remember how much it was, but it was thousands of litres of oil. And basically we dug down as much as we could, but there were still residual elements of contamination in there. So what we did is put this membrane in, seal it to the perimeter of the room, and then that stops any gases coming out. And the gases are important because they are a risk to human health. It also doesn't smell very nice, first and foremost, but it also can be quite harmful with long-term exposure, like I said before, particularly with children and pregnant women as well. The other picture there is pretty much the same job as the gas-resistant membrane, but that's called a liquid gas-resistant membrane, and we use that to paint on up structures or things that are difficult where we can't put a membrane on, or where it's cheaper just to do that. And how that works is the water, you put some water on the structure first and then paint it on the top, and as the water dries it draws the membrane into the building structure, and then you put another couple of coats on, and you've got basically the same impact as the other membrane. Is anyone familiar with absorbent booms or boom applications in streams or anything? Have you seen them on rivers or? No? Well, it's one of our most common immediate response techniques we can use. So say if we've got, on the picture on the top right where we've got a bank of oil, I think that looks like diesel or kerosene in there, in a stream, we can put these booms in the way to stop any contamination getting further downstream, because the first one thing we want to do is contain everything in one place. Once we've done that, we can then either recover it with that, see that weird looking thing on the bottom, it's like a blue ring with some red floats hanging out of it. That's basically that's called a skimmer. So you'll get the oil coming into the top of that, and it's attached to a pump in the middle, and it'll just draw out the oil from that. So you can put that in there, pump it away, and I'll show how we sort of separate that a bit later on. The top left is basically we can go in a stream and build a weir. So if we've still got a sheen coming in, it might be difficult to get rid of that. So we basically build a dam, and then we put a board underneath so we can get water coming underneath the one, and that's the one at the top. Water comes in from the top, comes under the first bank of sandbags, and is held back by the dam. The oil will rise to the top and rest behind the first row of sandbags, and we can pick it up with the absorbents then. And it just sort of speeds up the process of taking away that sheen. So going back to that slide up there where we've got the oil on the surface, we might find that against someone's house. So the first image up there is against, I think that's against like a nursery or a polytunnel. So we've dug down there, very shallow perched groundwater, and we found a lot of hydrocarbon contamination on the surface. So what we want to do is pump it out. So we make a window basically, put a pump in, and it comes. This unit at the bottom is what's called an oil water separator, and it works on the same principle as that weir interceptor up there. So your oil comes in the top, collects at the surface where you can collect that off and move it, and then the water will pass through and go through that large blue vessel on the top right, that tall structure there. It'll pass through that, and that's called a GAC vessel. GAC stands for granular activated carbon, and it's basically, I think it's made up of dried coconut shells ground down to create a larger surface area, and you can pass the water through and it will pick up all the contaminants that are on there, and then pass through the bottom. You can discharge it either to a river or a soakaway, and you have to obviously test that to make sure that your carbon doesn't need changing. I appreciate that's a lot to take in, so I'm just going to try and conceptualize this for you, which is another important technique that I sort of carried across from my degree. This property was over in the Lake District, and 2,000 litres of kerosene lost from a filter bowl cracked. The star on the right-hand side next to the borehole BH4 is the spill origin. We've got on the left-hand side, we've got the river, and you can see on the scale at the bottom, it's approximately 40 metres away from the river. 2,000 litres of oil, right, that's a problem. So we had to go in and, do you remember those drilling rigs that I went through, one of the early slides? The window sample rig. Basically installed those all around the garden, a lot along the perimeter of the banking to the river. And then from that, we established that there was a hydrocarbon plume on the surface of the water, which is measured there in red. And also there was a contaminant plume in the dissolved phase of the groundwater. And you can see that it's actually sort of migrated further in the dissolved phase there. It's also good example here of showing you how the drift deposits at a site can change and vary. So there we've got sort of a sandy gravelly clay at the top, made up of topsoils, quite permeable and managed to get through. Then we've got the gravel lens, which has got the water table in it, so that's constantly moving up and down, and it's very permeable. So you've got all this kerosene that's on there, it's moving up and down freely, nothing really stopping it, and it's just smearing everything up and down. And we don't want it getting on. If it gets onto the clay, that's an impermeable boundary. So usually it will stop in the top sort of surface of that. So what we did here is we put a number of what are called monitoring wells in, which are labelled WS. So we've got WS05 and 02 there. I think there were about 7 of those at this site. Sort of creates a fence around the plume. And we also put in 4 what we call abstraction boreholes, where we put pumps down the wells to recover the contamination. Additionally to that, we dug out the top 1.5 meters of soil across about 12 meters squared, I think it was. And then by doing that, you're taking away the source. There's a big bulk of source material, and once that's away, the rest of it will follow pretty quickly. So yeah, there's a few examples of what I've used here. So we've got conceptualizing information is really important, because we're trying to show an extremely complicated situation and an environmental issue to clients who may not be trained in environmental science. They might not understand the terminology we use. So if we can produce a plan like this, and it shows quite clearly where the contamination is, how far it's got, what the risk receptor is, and what we intend to do about it, it's really easy, and it allows us to get authorization for the rest of the works quite quickly afterwards. You also have to bring in elements. Well, I brought in elements of knowledge of hydraulic conductivity of groundwaters and rivers, delineating contamination, sort of laterally and vertically. There's your sampling techniques. I don't think I mentioned this earlier, but when you're taking a sample, you need to go ahead in the right procedure and in the right strategy as well. You've got to label everything up correctly, make sure you're organised with everything, or when you get back to the office later on, you won't know what each sample meant. And also, like a small understanding of geology will probably be helpful as well. This is another element of what we do, and actually a water company might say we've got this big pit, we need it dewatering, but we're afraid that there's contaminants in there. We're a big company, we can't just discharge it over the wall like Johnny Builder will do. So that's what we did here. So we dewatered this vat through. These are the carbon vessels, which like what I've explained before. But we've got a bank of 3 or 4 there, I think. And that basically does the same job. So that's another element that we can do. So yeah, one of the other things that's quite important about my job, so once we've got all the understanding of the field-based things I have to do, there's also the office-based work, such as managing the clients and managing the project. And these are sort of skills that anyone could have and should have, really. So when you're liaising with people, clients, householders, regulators, even in-house consultants or other consultancies, you need to be able to present clearly, communicate clearly. You need to be able to present it either with tables, diagrams, or the plans like I showed you before. But also a really important thing to do is to write report writing. And report writing is very much like an essay. It is different to an essay, of course, but it's very similar because you've done your investigation, you're collating a lot of information, a lot of data that you've got, setting the scene in terms of the site and the contamination that's there. And then you're pulling together what results you've got, putting those into context by risk assessing them against your human health risk assessments, risk to the environment, risk to building structures, and third parties as well. And then after that, you're drawing conclusions and coming up with suggestions. So it's really important to sort of be able to show that you can pull everything together and report in that way. You also have to be able to analyse data, be comfortable with data and comfortable with a lot of data, and being able to pull it all together. Particularly when you're dealing with the finance side of work, it's really handy to be good with Excel. I know a lot of people don't like Excel, but I sort of do. It's useful for when you're invoicing, cost estimates that we have to do as well. And also, when you have to get a lot of quotes in, if there's a lot of works that we can't carry out, or it's more cost effective for us to subcontract out, and that includes waste disposal, so you skip your lab analysis, plumbing and building work, so if you've got large scale building work, so taking plumbing features out or electrical features out, you might need to do that. So you need to compare a lot of contractors, think about are they right, do they have the right insurances, are they trustworthy, have you used them before, were they good or not, who's got the best price, and you also have to manage them when they're on site, so make sure they adhere to our health and safety paperwork, which I always have to write. You're probably all aware of health and safety. John likes health and safety, you might know. It's a really important part of the job. They won't be, I might be pulled up because I put it last, because it's not very interesting, but it is important. Because as a company, you can't be seen to neglect the safety of operatives who are working there. And a lot of the time you are more aware of the risks than other people might be. So you need to sort of make sure that they're expressed. So remember, I asked you to sort of think about skills you might have, and bearing in mind what I've just gone through and the techniques and whatnot I've done. Can anyone think of any skills that they have that might be applicable, or do you want to throw any skills at me that I can try and help you out with, see how they can relate? No? No one got any skills? Unskilled year of students? No? Sorry. Yeah. So there's a lot of you on laptops, but I guess you've all got phones, you should all be able to communicate with people. But if you get to an interview and they say, can you communicate with someone? You can't just say, yeah, and you just elaborate on it a bit. Elaborate, say, yeah, I'm very comfortable, I can do this, I can do that, I've presented such a thing to such a body, this happened. Anything else? Is anyone here doing a BSc geography? Yeah? So you've gone out and taken some sort of soil sample or done some sort of assessment. Have you done field sketches before? Yeah? Maybe not here, but school or whatever. Well, that's useful as well. We can have a think about that. So some sort of the challenges that we face as an industry, and it's not just us, it's everyone who's involved in this sector. Number one, changes in planning regulations, I think happened quite recently, have made it easier to develop greenfield land. So a lot of the remediation work and assessment comes from developers wanting to develop brownfield sites. And to do that, they have to risk assess the environment before and after. Obviously, if they can just develop a greenfield land, they might not have to do that to the same extent or at all. So there's less work from that. During the recession, there was a lot of companies that went bust and a lot of people that lost their jobs. So there's an element of a skill deficit now, where you've got an industry that's growing and continues to grow, both here and abroad. But you've got a people's deficit essentially. So people who have got skills that might be useful to them, and as long as they can sell themselves effectively, there's a good chance they'll be able to get a job, because people are employing all the time. You just need to sort of look hard and find it. Declining availability of landfill. So mentioned early on about when you're digging out soils or whatnot, you've got what can you do with it? You can either dump it all in a landfill. First of all, that costs, I think it's about £95 a tonne in tax, and you think you might be moving sort of 40 or 50 tonnes worth of material. It can get expensive, plus your actual disposal cost on top of that. So, and also you've got there's a restriction on the amount of landfill that we have in the world. So there's an emphasis on the industry to sort of come up with ideas for treating more contamination in situ. Competition, obviously, everyone's got competitors. There's different universities you can go to. There are different companies you can work for. None of them are as good as Manchester and Rowe, of course. You guys know that already. And emerging markets from international government policy change. So one of the reasons we're opened an office in China is because there was a shift in some of the larger companies and I think some of the governments that wanted to take up a responsibility of cleaning up some of the sites that they've used over the last 50 years worth of industrial development. It's quite commonplace here and in places like America and Australia, Canada and such, where they have to do that. But there's now, obviously, as countries develop, the idea is that they'll want to continue with that as well. And of course, there's a projected decline in fossil fuel use. So as we are at the moment, a lot of work coming in from hydrocarbon spills from fuel supplies for boilers and whatnot. That fuel supply isn't going to continue forever. So the industry and people in that section will have to change and adapt and find new markets and what they can get into. And that's everything. So yeah, thanks for your attention. If you have any questions now's the time to ask them. Yeah, thanks.